All right. So recording has started. So hi everyone. Thanks for having me. I know I missed a couple of these sessions, so I'll try to join in future. So today's talk is focused around distributed architecture in a multi-cloud environment. Um, what what we'll do in this talk is we'll talk about how at Cloudanix we are following a distributed architecture while sort of deploying our workloads across multiple cloud environments. And one of the objectives that I have is to share what is our architecture, why we have this type of multi-cloud architecture, what are some of the benefits that we are getting out of it, and also what are different components that we are using to make it happen. And towards the end, we'll talk about what are the challenges and future growth areas as well that we are looking at for future growth. So before we start, I am Purusottam, co-founder of Cloudanix.com. So at Cloudanix, what we do is we provide a cloud security monitoring and remediation platform for public clouds. When I say public clouds, it's AWS, Azure, and GCP, the major public clouds. And as part of the platform, we are sort of covering three areas. One is the cloud security posture management. The second one is cloud infrastructure entitlements management, and the cloud workload protection platform. And what we do is, as part of our offerings, we help the security teams and CISOs sort of get an idea about their infrastructure security, public cloud infrastructure security, and then we help them remediate them as well, so that their posture improves towards a better direction. So with that, so this is the agenda that I was thinking. One is we'll go through the architecture, then a couple of areas like how we are securing the architecture, how reliability, like how we are getting the reliability aspect, scalability aspect, monitoring, and stuff like that. So before I get into the architecture, very early on, we decided that we'll have workloads across clouds to get few advantages. One is, since we are a security platform and we are sort of monitoring our customers' cloud infrastructure, which is either hosted in AWS or GCP or Azure, we made one choice to sort of run the workload in the respective cloud environment. If a customer's workload is in AWS, then we run our workload as well in the AWS. If the customer's environment is in GCP, then we run our workload in GCP, and same for Azure as well. And there are two reasons for that. One is performance, and the second one is cost. So when I say performance, when you are running your work, when you are trying to connect with the customer's environment, running in the same cloud provider always gives you a performance advantage, because you are not going cross cloud. You're within the same cloud, and the API responses and stuff like that are always faster. So that is the first aspect. And the second aspect is cost. When I say cost, we could have run all of our workload. So our primary cloud that we use is GCP, Google Cloud, where our web experience is hosted. We could have run all of our workload in GCP as well. But if we would have done that, then all the calls, let's say if a customer's infrastructure isn't running in AWS, then if we need to get any metadata about a customer's environment, all the calls would go from GCP to AWS. That's like network cost and also like actual dollar cost as well, because you have like ingress and egress charges, so those would be applied for your API calls. So to keep that simple, and also from a cost perspective, we sort of started adopting these three clouds. Now our workloads are deployed in all of these three sort of cloud providers. Any questions before I get into the architecture? Okay.
Anyone have any queries? My queries is like you said, like you are mentioning the major cloud provider, right? So other than major cloud provider, for example, if someone is deploying to other cloud provider, right?
Yeah, let's say
So
VMware or
yeah,
Oracle Cloud or something like that. Yeah, okay.
yeah. So in that situation, also you guys also deploy your workload over there. How you handle that one?
Right. So there are two approaches that we can take. One is we can always do like native workload deployment. The other approach is we have APIs as well, where customers can send their data using our APIs. So we don't have to deploy anything in the customer's environment. Customers can push the data to our platform as well. But to answer your question, like simply, yeah, the first approach, preferred approaches will sort of deploy our workload in that environment. If the customer is using Oracle, then we'll deploy it in Oracle Cloud.
Okay. Yeah, that's all from my side.
Okay. All right. So I'll continue. So if you look at the architecture, like there are two major components. One is our web experience, and the other one is the serverless architecture, which we are running in AWS. And we have similar serverless architecture hosted in both Azure and GCP as well for cloud specific workloads. So all of our users interact with our web console, and that is hosted in our Google Cloud. And all the data and everything is stored in PostgreSQL database in GCP itself. And whenever a customer connects one of their infrastructure, so that we sort of audit and do all of our provide our capabilities, all of that gets stored in the OLTP. And then we have our job scheduler, like we use Rails delayed jobs job scheduler, which reads from OLTP and sees what jobs has to be run next. And what it does is it sends the payload to, let's say in this case, AWS. And the first component that it interacts with is the API gateway. So that is AWS's offering, which acts as like your API interface. So job scheduler sends the payload to API gateway. Now, first thing that API gateway does is validates that whether the request should be honored, like whether the user is authorized to make the request. And that's where this Lambda authorizer comes to the picture. So as soon as job scheduler makes a call to API gateway sort of forwards that payload to the Lambda, and Lambda sort of validates that whether the request is valid or not. If it is invalid, then it returns like a invalid request, and like there are different HTTP error codes that we return, or you are unauthorized and stuff like that. If the user is authorized, API gateway then forwards to our request router, which is again Lambda function written in Python. So now this Lambda function's responsibility is to sort of validate the schema, check the request payload, and do all of that. And all it does is it sort of routes the request to different sort of SNS pub/sub topics. This is very lightweight. It doesn't have a lot of business logic. All it does is it reads the request and sort of posts that message to different topics based on what type of request it is. And once that is done, it sort of acknowledges back to the job scheduler saying that, hey, I received your request, it's getting processed. So this acts as an asynchronous request by this time. Now, SNS or the pub/sub has a push-based mechanism where these topics, they push the payload, whatever payload was sent from the job scheduler, to our background functions, which are again like Lambda functions written in Python. So these sort of pub/sub SNS topics, they push the payload to another Lambda function. This is where our actual sort of business logic is implemented. This is where we make external API calls or database calls and stuff like that. All of that happens here. And once it is done, it sort of posts the response to another sort of pub/sub topic or SNS topic. And if, let's say, the request processing fails or it times out or something like that, SNS has a retry capability so that it retries that for a couple of times, and after that it sort of pushes it to a delay, dead letter queue. But the retry is all handled by the SNS capability. Then once the processing is done, the response is sort of posted to another SNS. This SNS has one responsibility, that is to send that payload back to our webhooks. And here also, SNS or the pub subs have they follow an at least once delivery model. Let's say when the SNS is posting that response to webhooks, for some reason our webhooks are not available, SNS does a retry. The retry is inbuilt. And then once that response is delivered to webhooks, webhooks sort of populates everything in the SQL or in our OLTP database. And when the user interacts with the web console, they can see the latest results. And similar to this AWS, we have in GCP and Azure as well, where we use different components. Let's say instead of Lambda, we use like functions in Azure. Instead of SNS, we use Event Bridge in Azure. Similarly, functions here or Event Bridge. So different components, but overall from a responsibility perspective, they do very similar things, but we use different components for different clouds. Any questions on the architecture side?
Hi, Puru. This is JK.
Hi. Hey.
Hey, how are you? Sorry,
Good. No problem. Any questions so far?
Yeah, one question. So again, I mean, I don't think I saw your presentation before, so I don't know what I'm asking is even makes sense or not, but let me know. So is your solution basically a way to monitor a cloud infrastructure or?
Yes.
Okay.
Yeah.
And like, I mean, how it is, I'm just trying to understand, right? So if you talk about Azure, AWS, they have their one web interface, whatever you get out of the box, right? So I'm trying to think in terms of some advantages of this over those. So maybe if you could,
Sure.
Yeah,
cover
those along the way, I guess.
Oh yeah, absolutely. So there are a couple of differences. One is AWS, Azure, all of them are focused on a per account or per cloud, per project basis. Like when you go to AWS, you can create multiple accounts, or when you go to Azure, you can create multiple subscriptions. So the security offerings that these cloud providers have are very focused on a single project or account. What we are doing is we're sort of building that holistic view. If you have multiple accounts, then we sort of aggregate all of that information. Or if you have multiple clouds, we sort of aggregate that as well. So you get that holistic view of your entire infrastructure, not specific to a cloud or a specific account or a project, but rather like a holistic picture. And the second difference is we go very deep into audit and real time as well. Like even today, AWS doesn't offer audit for all kinds of compliance families. That's where we get come in. We support a lot of compliance families, and we have a lot of rules as well where we evaluate and we tell you what is your security posture. I hope that answers your question.
Yeah, that makes sense. Yep. Thanks.
Okay. Okay. Any other questions? Otherwise, I'll continue. Okay. For now, I'll continue. If you guys have any questions, just feel free to stop me. Okay. Next is like, since we have a security solution, we have taken security seriously from day one. And some of the measures that we have implemented, I spoke about them a little bit, but in the architecture slide, but some of those are like custom Lambda authorizers to authenticate the request. So this is where, let's say, when our job scheduler makes a call to our backend services, the API gateway uses a Lambda authorizer to validate that, hey, the request is valid or not. And we use like an API key and some additional like jots as well to make sure that the requests are valid. And that's where the first step comes into picture. The second one is, which is highly recommended by AWS, is you should keep your workloads within a VPC. And for us, the workloads are like Lambda or API gateway or your kinesis or your SNS, all of those components, we keep them within a VPC so that we can always control who can access, like whether it's exposed to public or not, whether like which components can interact with which other components. So we keep all of them within single VPC. So that is the second thing. Third and the most important one is the least privilege for the IAM role. So whenever we like create a component and whenever we deploy something, all of the components need access, have IAM roles associated with it so that they can take action. Let's say in our case, Lambda can sort of post a message to SNS. So you have to create a role so that they can interact. Those two components can interact with each other. So one of the things that we have done from day one is all the roles that we create specifically around Lambda, we made sure that they have only those permissions which they need. And we don't provide like wildcard permissions so that they can access all the resources or all the different types of services and stuff like that. We only provide access to specific topics and specific services. So that's we have focused from day one. Next is this goes sort of hand in hand with the Lambda authorizer, is where we use API key and rate limiting capabilities in the API gateway layer, so that we can avoid any threats and abuse of the API or abuse of our like backend services. This to keep in mind that in future, if we open up some of our services to our customers or external world, we need to make sure that all of them have rate limiting and enforced, so that one customer cannot bring down the entire infrastructure, like entire infrastructure of ours. And the last one is API gateways have a capability where they can generate like SSL certificates. And those certificates, you can you generate the SSL certificates and you can pass the public key to Lambda, so that each time whenever Lambda receives a request, it can always validate that it is coming from an API gateway. So that sort of ensures that even if by mistake our Lambdas become public, they are always protected, because whenever there is a call, it always checks that, hey, who is the caller? Like, does the certificate match? Only when the certificate match, the Lambda is invoked. Otherwise, like an error is returned. So these are some of the security aspects that we have in place for our workloads, like Lambdas and PubSub and stuff like that. Any questions on the security slide?
I guess one question. So is there anything in terms of security that you will not be able to do from your solution, and you actually do have to go to respective cloud provider and do it?
Yeah, so that's a good question. So what happens is these cloud providers, AWS or Azure or GCP, they provide a lot of, they add new services sort of every month, right? Sometimes we cannot catch up to them that quickly. So that's where what we have done is we are also taking the security data, like security output rather, from the cloud providers, and we ingest that into our dashboard, so that even if, let's say, recently last month, AWS released EKS anywhere. Like you can deploy Kubernetes like you can deploy Amazon's EKS implementation in any cloud. So before we could build any offerings around it, we can always consume Amazon's like security findings, and we can show that in the dashboard. So that is much easier to build. So that's one of the areas we are sort of using their security data.
Yep, thanks.
Yeah. Any other questions? Okay, I'll continue for now. So the next aspect is, since we are running across cloud, and since we are running like a serverless workload, how do we ensure that our platform is reliable, right? So for that, we again, I have spoken about a few of them in the architecture slide. But what we do is we sort of use an asynchronous model, where when the scheduler makes a call to our backend services, it's not synchronous anymore. There is a request router in between, which just posts the message to a pops up, and sort of an acknowledgement is returned to the job scheduler saying that, hey, we have received the message, and then the actual processing of that message happens later on. Later on, as in it happens near real time, but it doesn't make the job scheduler wait for the processing to complete. Rather, we handle it through our background functions. So that is where the event-based Lambda invocations help us. And it also has the retry capability. Let's say for some reason our business processing fails, or it times out, or something happens, then there is inbuilt retry capability provided by SNS. So that always helps us. Second is the retry. It doesn't happen just once, it happens multiple times, and you can always configure that as well. And you can define the delays in between. Like, do you want to retry right away, or you want to wait for a few seconds and then do a retry and stuff like that. So we have configured that as well. And then the third aspect is, let's say we retry for a couple of times and still the system is failing, our background functions are failing. We have defined a threshold after which the requests go to dead letter queue, because we don't want to sort of overload our background functions where it is anyway going to fail. For example, let's say, I'm just taking an example. If we are calling Facebook API, it's this Monday Facebook was down for 6 hours, right? So in that case, we don't want to like retry for 6 hours continuously. Rather, after five retries, we sort of say that, hey, we will not process this request anymore. We put it into a dead letter queue. And then from dead letter queue, we get notified that, hey, now there is a message in the dead letter queue which could not be processed. So we sort of investigate what was the reason and stuff like that. And then we can always sort of put that message back to the queue in a different way, where at least it doesn't sort of clog the processing on our side. Then the last aspect is, once everything is processed, when the response is posted to the response topics, the response topics responsibility is to post that to the webhooks. And that also we use SNS, which is the PubSub based mechanism. And that sort of has at least once delivery model. And that sort of ensures that even if your webhooks are not ready, your PubSub will do a retry. And it will make sure that you receive that response at least once. And then once you receive and acknowledge, then PubSub would sort of get rid of that message. And that ensures that it's always reliable. If we process the message, we always receive that response on the webhook side, or on the web experience side, we receive that message. Any questions on the reliability slide?
Quick query, I'm just curious. So when you mention the retry happens multiple times, this multiple times is kind of like static or it's dynamic? Like it should be like, okay, we are going to retry an n number of times, or it depends on the the request, okay, we'll do this much time and then let's leave it.
Yeah. So currently we have defined 5 times.
Okay.
But you can always do based on parameters. Let's say in your payload, you can always say that, hey, retry it for a couple of times. But in that case, it becomes a little complicated because in the business logic itself, you are embedding the retry logic as well, right? So we have stayed away from that, and we have sort of hard coded it for now to 5 times. And even after five times, if the request is not processed, we sort of send it to dead letter queue.
Okay.
Okay. Okay. The next area is around scalability. So this is where, again, based on we have what we have done is in the job scheduler, we have made sure that we don't call our backend functions at the same time. Like we made sure that there is enough gap in between requests. But even then, if let's say a customer connects their account who has 10,000 servers or 2,000 databases and stuff like that, if they connect, whenever a customer connects, we always run their audit right away. So we cannot like 100% manage that like gap between requests. So in those scenarios, to make sure that our platform is working, we have taken some steps. Like one is like AWS has a capability called provision concurrency. So you can always define what is the minimum number of instances should run, what is the how does it scale up, and what is the maximum number of instances you can run and stuff like that. So all of that we have defined in the AWS Lambda, so that if there is a higher load, our Lambda scale up automatically. So the next is we are using some of these components, right? Like API gateway. API gateway today supports like up to 10K requests per second. Lambdas can process like 1,000 requests concurrently. And also Lambdas, like you can vertically scale them from like 128 MB memory to all the way to the 10 GB. It all depends on your workload and what type of process you are running as part of the Lambdas. For example, our request router, it doesn't it doesn't process a lot. It just receives the request, does some basic validation, and then posts the message to the pub sub. So we use like a 2 GB memory Lambda versus our background functions, which do a lot of work. Like it interacts with a lot of like databases, or it makes external API calls. We have kept it as 4 GB memory. So you can always manage how much memory you need, and it can scale all the way till 10 GB. So we have that flexibility. And then the last part is around our background jobs. Since they sort of scan our customer's environment for metadata and stuff like that, it takes a lot of time depending on our customer's environment. If a customer has like 10 VMs, it might complete within 30 seconds or a minute. But if a customer has, let's say 10,000 VMs and they have enabled 500 rules, in that case, it takes quite a bit of time. And today, as of today, AWS's background jobs support a timeout of 15 minutes max. So, and we have enabled this to 15 minutes to make sure that we don't fail, even if there is a larger, larger volume of resources that our customers run. So these are some of the scalability aspects that we have incorporated in our platform. There are many minor ones like implementing threading and stuff like that. I'm not going into program level scalability aspects. This is more of a infrastructure level scalability aspects that we have implemented. Any questions on the scalability slide?
This scalability looks like we are much more covered from the AWS point of view, right? So the same thing, if we are implementing any other cloud provider, it might be totally different, right?
Right. So GCP, I'm just taking an example. Like as I was saying, AWS supports till 15 minutes, but GCP has a 9-minute hard limit. So if you go beyond that, it times out and it fails, and there would be a retry. But yeah, you're totally right. Right, like
because
in
you
case
mentioned, yeah, you mentioned the provisional concurrency, for example, has been provided by AWS, might be like other cloud provider might not provided that kind of like the functionality, you know.
right. So Azure and GCP also has provisional concurrency, but when it comes to these limits, right, like how many requests you can process or how many concurrent requests, each cloud provider has different supports. And even like memory, from a memory standpoint, also each cloud provider supports different minimum and maximum memory requirements. So yeah, I just for this talk, I have focused heavily on AWS, like what we have done on in AWS and how that has helped us. But yeah, you're right. Okay, I'll continue for now. So the next aspect is around monitoring. Like now we have our architecture and everything is running. How do we monitor our services and all the requests that we are processing and stuff like that? We heavily use CloudWatch logs. This is very native to AWS again. And GCP and Azure offer similar capabilities. Like in GCP, you have logging, and in Azure, you have monitoring. They call it monitoring anyway. So we use those capabilities. And what we do is we log requests, throughput, errors, latency, all that information to CloudWatch logs. And just as an example, if there is any delay in processing, or if there are any errors, or if something failed, then we always go into CloudWatch logs, and then we look at the request. We try to trace the request, how far was it processed, where did it fail, how much time did it take, and all of those we do through CloudWatch logs. The second area is we have alarms set up on top of the CloudWatch to capture, let's say, if we have Lambdas, how is the memory usage performing, or how is the CPU utilization performing, or what are the error rates of our CloudWatch, not the CloudWatch, the Lambdas and the pub server and stuff like that. And we get notified if, let's say, the memory usage goes goes above 80%, or the CPU usage goes above 75%, so that we can always look at how, what is the traffic pattern? Is it that there is a customer who has signed up, who has a higher volume in terms of infrastructure, or because of retries, or some APIs are failing, or the error rates are high? So we use CloudWatch alarms heavily for that. The third aspect is we use a capability called X-ray, which is offered by AWS for tracing. So once we receive the request to the API gateway, all the way till when the response is sent to the webhooks, if we need to trace a request, if we need to find out where exactly a request failed, we use the tracing capability using X-ray. And for that, what we do is for each request, we make sure that we provide like a request ID, which acts as the identifier and helps us in tracing the request throughout the backend services. Any questions on the monitoring side? Okay, I'll continue. So now, so far I spoke about our architecture, what are some of the components that we are using to achieve scalability, reliability, and stuff like that. With a multi-cloud setup, with serverless architecture, there are several challenges as well. The first one is cold start times. So Lambdas or serverless technology, with serverless technology or Lambdas, one of the benefits is you sort of pay for whatever services you use, or for however long you use it. And if Lambda is idle, if it is not invoked for let's say 15 minutes or something like that, AWS shuts down that Lambda. So there is no Lambda, there is no presence in your infrastructure, so you are not paying for it. That is good from a cost perspective. But the moment you get a new request, it takes a bit of time to sort of provision your instance and make the infrastructure available so that the request can be processed. And generally that is called cold start. And depending on the workload, sometimes it can span to seconds. Like for our use case, we have seen up to 5 seconds when the Lambda is not ready to process, and we are trying to figure out how exactly to sort of avoid that. And some of the things are like provision concurrency. If we can provision one resource to make sure it runs all the time, or we can say that the idle time check can we increase from 15 to 30 minutes and stuff like that. So that is one of the challenges that we are working with. Then concurrent request limits, like as I was saying, right? Lambdas can process up to 1,000 requests per second. But what if we have, like, as we scale up, if there are more than 1,000 requests, then they have to wait till the earlier requests are processed. So there is that concurrency limit that, and this is a hard limit that we cannot sort of change right on the fly. So we have to be careful around that. Then another thing that I was saying was background functions have a hard limit of 15 minutes. What if the processing time, it takes more time to process, like scan our customer's environment and evaluate our rules and return a response? What if it takes more than 15 minutes? Retry will never fix it, right? Even if we retry, the API consumption of like making an external API call, getting the data, doing all the process may not complete in 15 minutes ever. So how do we handle that? So that is another area. And one of the biggest challenges with a multi-cloud setup is observability across clouds. So our requests are initiating from Google Cloud, but they go to AWS or Azure or GCP again. How do we trace that? Where did the request fail? We can always see it within the AWS. But if there are some actions, some tasks which are being performed in GCP before it is sent to AWS, how do we track where exactly it failed? But today, what happens is we have to look at both the systems. Like we would go into GCP to see how far did the request proceed, and then we take that request ID and we go to AWS X-ray and we see, hey, where did it fail or how far it processed and stuff like that. We don't have that centralized sort of observability for all of our requests. So these are some of the challenges. Apart from these, like there are minor challenges as well, but yeah, these are some of the major challenges that we are facing because of the way we have designed our architecture. Any questions on the challenges part? Okay, for now, sorry.
Puru, I was just thinking, like for the multi-cloud environment, means like if you are implementing, for example, Azure, AWS, the architecture might be the same one, right? But when it goes from one cloud provider to another cloud provider, is it going to be asynchronous? For example, the asynchronous is like when it goes from, for example, GCP to the AWS, it's going asynchronous, right? And from AWS, if you are calling any other cloud provider, whole like is the asynchronous. If whole like the asynchronous, we don't know like if it's failing somewhere, we don't know like which one is failing first and which one is failing last, those kind of things, right? So you never know, right? Yeah.
Okay.
So
that is where within AWS we are able to figure out using the X-ray.
But if you have,
but when it comes to end to end, that is that challenge that we are facing.
Yeah. And another thing I'm thinking, like when you mentioned the 15 minutes, I'm thinking why might be because of the serverless, they are trying to make like 15 minutes so that people will not pay much more money. Right? That's the reason that they are making the timeout at 15 minutes, Like I was thinking like why they are making 15 minutes.
And also there are like several. Sorry, go ahead.
Yeah, might be, I don't know, the reason that I was trying to figure it out, why they are making 15 minutes, why it's not like more than 15 minutes, or why it's not the configurable kind of stuff. Might be the serverless functionality, so that people do not need to pay more money, like after 15 minutes, just timeout.
Yeah. And also, there are several other, like two things. There are several other hard limits as well. Like Lambdas have a maximum limit of like your deployment package size of 500 MB. It cannot, sorry, no. Yeah, I think 500 MB. It cannot go beyond that. If you are deploying something which is bigger than that, you cannot deploy in a Lambda. Or for this timeout, right? I think there are several other offerings as well, right? From Lambda, from AWS side. They're rather promoting that you use those, because if you're running it for more than 15 minutes, then it doesn't fit into the serverless philosophy, right? Because you are running a payload for or a request for that long. So that's where they rather suggest you do like a Kubernetes or a hosted EC2 approach or something like that.
Okay, makes sense.
Yeah, and I'll talk about some of those in the next slide actually.
Okay.
All right. So let me go to the next slide. So the next slide is the growth area. Like we have challenges, we have architecture built in, we have challenges, and how do we see like in future, how can we overcome some of the challenges, or how can we grow further, right? So I'll start with the cold start actually, then we can sort of go through the others. So the first one is cold start, right? Where I was saying, let's say sometimes for the Lambda to start processing requests, it can take up to 5 seconds, stuff like that. One of the things that AWS recommends is have a higher memory machine. Like as a from a cost management perspective, what do you think is the smaller the memory size, the smaller the bill. Like we will not pay a lot of money for that, but sometimes it takes more time to sort of start those services. And recently I was reading that they generally recommend you have at least 1 GB or 2 GB, so that you should not use 128 MB or 256 or 512, because that takes more time to boot up or start processing your request. So that is one area, like having higher memory machines. Next is we have API gateway, right, which sort of receives the request. API gateways can integrate with the WAFs or web application firewalls, which provide some of the security capabilities. Like they can check for SQL injection or cross-site scripting, or you can even sort of whitelist IP addresses. Currently, all the calls to our backend services, all of them are coming from our own job scheduler, right? So you can always whitelist that, hey, only accept requests coming from these IP. So you have some of those capabilities provided as part of the web application firewall, and that can sort of integrate with the API gateway. So that's one area. We haven't incorporated that, but that's one area we'll be looking into in future. And this will help in the security aspect. Then another area that we are looking at is like for error reporting. Like we have so many services now, right? We have job scheduler, we have the webhooks, we have the Lambdas, multiple types of Lambdas. So all the errors that gets generated, we are sort of integrating. We have actually started evaluating, and we'll integrate with a platform called Sentry, so that you can see all the errors happening in your platform across all of your services at one location. And Sentry has a very good way of capturing context as well. So you can say that, hey, this failed, and this was the payload, this is the context associated with this request, so that whenever you are trying to debug the error, you can always look at the context and you can debug it in a much better way. Then another area is for the observability. We are also looking at some of the platforms like Grafana or Prometheus, so that we can sort of, from all of these components that we are using, we'll send the tracing data to let's say Grafana, for example, we'll send everything to Grafana, and then we can go to Grafana dashboard to trace requests end to end, starting from all the way from the job scheduler through all the backend services and through the webhook, so that we can see a request journey end to end. And if it fails, then we can always figure out easily where exactly it failed, and we can start debugging that. So the last area is, since we are using serverless heavily, Kubernetes also has support for serverless functions. So this is one area we are thinking of evaluating to sort of overcome some of these challenges, like the 15-minute request or a 15-minute timeout or 1K request and stuff like that. To work around that, we will be soon looking at these platforms like either Kubeless or Knative, so that we can sort of deploy our workload using Kubernetes serverless functions, and we'll not be worried about the timeouts and stuff like that. And this is in our sort of roadmap. We haven't sort of set a timeline around it, but this is something we'll be looking into in future. All right. So that was all that I have put together. Any questions that you guys have that I can help answer?
Let me quick ask you the last one, the Sentry, right? Sentry you mentioned.
Sure.
The centralized error reporting. What is Sentry? Is this name? I don't know. I never heard that one. What is that one actually? Is this just the name, or like what is that one?
So it's a not an open source. It's a product called Sentry.io.
Okay.
And you can integrate with it to send your error information there. All the error log and everything you can send there.
Okay. So that means like the cloud or the service, whatever service in the different, like a cloud provider, if some exception comes, you need to send to the Sentry, which means you need to again either consume their API and then send it to them, right? Like that way, right? If I'm right.
Yes. Yeah.
Okay.
So
okay.
So far we have integrated Sentry with our Ruby application, our web experience, which is written in Ruby on Rails. And we use Sentry's Ruby SDK so that we can send the error information or logs information to them. And then we go to the Sentry's dashboard and we can see all the errors those are happening.
Okay. That's also a cool idea, Sentries.
Yeah.
Right. Yeah.
Mm-hmm.
Yeah. Anyone have any further queries?
Okay.
Okay.
Yeah. If you guys have questions in future as well, you can always reach out. Last thing is we are hiring. And we are mostly hiring for Python, Ruby on Rails developers. If you guys know anyone who is looking for a change or who is interested in joining a startup, then yeah, please send them towards us.
So Puru, you guys are hiring only in United States or India, Nepal? It doesn't matter.
It doesn't matter actually, because we are a pure remote company. Most of our team is in India. And the only person here. So our working nature is remote. So yeah, it doesn't matter.
So, and when you guys are said hiring, like you guys need like the experienced one or the one who just finished who just learned the Python, or you guys need someone who have like years of experience in Python or something? What's the criteria?
Yeah, so all of that is in our careers website. So currently we are looking to hire a senior Rails engineer, Ruby on Rails engineer, and a senior Python and few like junior Python engineers.
Okay. Nice. Yeah, if someone is interested, just you guys can note this one. So Gita, if you are interested, or if your friend are interested, why I ask Puru is Gita, who is here. She is she has started into the software field, and she learned. She's so I mean, she's so interested in software field, but she do not have the years of experience. That's the reason that I mentioned all this stuff.
Oh yeah, no, we are hiring like freshers or junior engineers as well.
And
Geeta, whenever you are ready, you can always reach out.
And she's from Nepal, by the way, just to let you know.
Oh,
she's in
as
Nepal.
I said,
she's in Nepal. Just to let you know.
Oh, okay.
I mean, yeah, okay.
Yeah, as I said, right? We are not focusing on US candidates or India candidates or anything like that. We are looking for good engineers who can write code and who are open to challenges, right? Like learning something new and working with something new.
Puru, so regarding this one of my friends' brother is completed engineering recently, and he's got a job, and he is well in Python actually. So can
nice. Sure. And he's here or in India?
He is in actually Hyderabad.
Okay. Yeah. Sure.
Okay. I'll ask him to send a resume and I'll forward.
Yeah. Absolutely. Absolutely. All right. I'm stopping the screen share, but yeah, we can still chat. Any other questions where I can help?
Yeah, I lately joined, so I don't have much questions actually. So from the beginning, and this cloud point of view, I have a very less knowledge. On the web applications point of view, a bit knowledge, that's it. So yeah, now I've started to exploring the things. So let's see. Next time I will give some kind of a demo here with the AWS.
Sure. Yeah, absolutely. And as I said, like if you come up with any questions, you can always like reach out to me as well.
You are maintaining the same number or a different number now? Mobile number?
Same.
Same. Yeah, please go ahead.
Okay, so if anyone have any kind of like a queries, they could actually, I have created a LinkedIn and everyone over here are in that group actually. And through that group, you guys could ask to the Puru any queries, the LinkedIn, go to the LinkedIn and go to the group and ask any kind of queries if you have anything.
Yeah, that works as well.
Yeah. So let me tell you like our next webinar session is going to be, I think most probably I'm planning to cover the next webinar session. I'm not sure whether you guys are interested. Let me ask you guys, right? So I'm thinking whether to cover the Angular or the Ionic. I mean, which one you guys are interested? Angular or Ionic?
I do not have a lot of experience in like front-end development. So and mobile as well. So I'm open to both, but yeah, maybe Angular because at least I can work on that. But mobile is a different beast, right? Altogether. Yeah.
Yeah. Okay. Then let me cover the. Anyone have any suggestion?
Angular is good.
Okay. Cool. Okay. Then. Sanjay. So Puru just wrap up his presentation. If you have any queries over there, you just come back, right?
No, I'm good. Yeah, thanks for the presentation. I think it's very good, helpful. So yeah, I missed the last part. Yeah, very into it stuff.
Yeah, so we have the recorded one. So whenever you got a chance, Puru, send it to me actually. And then what I will do is I'll put it to the YouTube so that everyone, whoever missed this one, they could watch over there.
Okay. Let me stop the recording.
Yeah.